A very warm welcome to the class, children. So today's topic is triangles part 10. In the previous video we had started solving the problem set 3. In today's video we will continue with the rest of the sums. So your first sum says, that is question number 4. In figure 3.59, point D and E are on the side BC of triangle ABC, such that BD is equal to CE and your AD is equal to AE. You need to prove that triangle ABD is congruent to triangle ACE. So these two triangles you need to prove are congruent. So already you can see that AD is congruent to AE is given and BD is congruent to CE is already given. So we need one more condition, okay, to prove that these both are congruent. So it can be either a side or it can be either an angle. So in this case we can use an angle. So you can see that ADE and your AE, your AED and your AEC are forming a linear pair, isn't it? They are forming a linear pair. The similar way, your angle ADB and angle ADE are forming a linear pair. So with the help of this information, we will try to solve and prove that these two angles are congruent, and we'll prove that triangle ABD is congruent to triangle ACE. So let's begin. Given point D and E are on side BC of triangle ABC and such that BC is equal to CE and AD is equal to AE. We need to prove that triangle ABD is congruent to triangle ACE. So your proof starts. We'll take first angle in triangle ADE. Okay, now taken triangle ADE. Their AD and AE are congruent. So with the isosceles triangle theorem, we can prove that angle ADE is congruent to angle AED. Okay, so in triangle ADE, it is given that segment AD is congruent to segment AE, which is given. Then they have given as angle, so therefore angle ADE is congruent to angle AED by isosceles triangle theorem. Okay, then as I said, with the linear pair, your AEC plus AED are forming a linear pair. So we'll write that angle AEC plus angle AED is equal to 180 degree. Reason is linear pair. Similarly, on the other side also you can see that ADE plus ADB is equal, angle ADE plus angle ADB is equal to 180 degree, again linear pair. So angle ADB plus angle ADE is equal to linear pair. So now you can see in the third and the fourth statement that the right hand sides are equal, so automatically the left hand sides also become equal. So let's write that angle AEC plus angle AED is equal to angle ADB plus angle ADE. This is from 3 and 4. 3 and 4. So you can see we have already given as we have proved that angle AD is congruent to angle AED. Okay, so I will just cancel this ADE and AED. So we are left with what? We are left with angle AEC is equal to angle ADB. So angle AEC is equal to angle ADB. So I will write here angle AEC is equal to angle ADB. That is from 2. So now we can see that in these two triangles ADB and triangle AEC. AD is congruent to AE, BD is congruent to EC, and just now we proved that angle AEC is congruent to angle ADB. So they both triangles are congruent by side angle side test. So let's write down that in triangle ABD and triangle ACE, the segment AD is congruent to segment AE, it is given. Then segment BD is congruent to segment CE, again this is given. And the next thing, angle ADB is congruent to angle AEC, that is we have proved from the sixth statement. So therefore you can say that triangle ADB is congruent, or you can say ABD, okay, which is there in your question. So you can say triangle ABD is congruent to triangle ACE by side angle side test. Okay, let's move on to the next question. The next question says, in figure 3.60, point S is any point on segment on the side QR of triangle PQR. You need to prove that PQ plus QR plus RP is greater than twice of PS. So here can you we had done the theorem where we had seen that sum of the two sides of the triangle is greater than the third side. So we are going to use that theorem in solving this question. Okay, so initially I will take the triangle PQS. Okay, so then PQ plus QS is greater than PS. Why I am taking PQ this side on the left hand side? You can take either of the two sides, children, but as we need to prove the PQ is on the left hand side, so I will take PQ plus QS is greater than PS. Similarly, when I take triangle PSR, I will say that PR plus SR is greater than PS. Again I am taking PR on the left hand side because we need to prove here. Okay, so let's write down, given that point S is any point on side QR of triangle PQR, you need to prove that PQ plus QR plus RP is greater than twice of PS. So proof, first we will take in triangle PQS. This is the triangle PQS. In PQS, first PQ plus QS is greater than PS. Reason, sum of the two sides of a triangle is greater than the third side, then its third side, correct. Then secondly, in triangle PSR, PS plus SR is greater than PS. Sorry, PR plus SR is greater than PS. Again the same thing, you will write it here. The reason that sum of the two sides of a triangle is greater than its third sides. So then, now by adding the statements 1 and 2, here you have to write, children, the entire statement. Okay, so I'll write PQ plus QS plus PR plus SR is greater than PS plus PS. I've just added the left hand side, that is PQ plus QS plus PR plus SR is greater than, that is greater than PS plus PS. Now you can see QS plus SR is nothing but QR, isn't it? QS plus SR is nothing but QR. So instead of this QS and SR, I will write down as QR. So it would be PQ plus QR plus PR, and this PS plus PS would be twice PS. So hence we have proved this, okay, that PQ plus QR plus RP is greater than twice of PS. So you will write down as PQ plus QR plus RP because it is in the proof as that PR and RP are the same, but you will write it whatever is given accordingly into the to proof, okay, in your question. This is your sixth question now. In given the figure 3.61, the bisector of angle BAC intersects the BC at point D. Prove that AB is greater than BD. You need to prove that AB is greater than BD. So whenever we have to prove that one side is greater than the other side, we need to prove that the angle opposite to that is greater. Isn't it that we had studied according to the property? Now we need to prove that AB is greater than BD. So which is the side opposite to, or the angle opposite to the AB side? It is angle ADB. Correct. So we need to prove that angle ADB is greater than angle BAD. Then only we can find out. Okay. So they have mentioned that AD is the bisector. Correct. So BAD is congruent to DAC is equal to half of your BAC because they both are equal. So BAD is equal to DAC is equal to half of angle BAC. Okay. Then we can say that ADB is an exterior angle. So when we say an exterior angle, that means the exterior angle is always greater than the two remote interior angles. So in this case, we would take this angle DAC as a remote interior. Okay, and we'll try to prove that your angle ADB is greater than BAD. Okay, so let's write given in triangle ABC, bisector of angle BAC intersects side BC at point D. You need to prove that AB is greater than BD. Okay, so prove the bisector of angle BAC intersects side BC at D. Therefore, you can write angle BAD is equal to angle DAC is equal to half of angle BAC. Correct? Then I said that angle ADB is an exterior angle. Okay? It is an exterior angle of which triangle? Of triangle ADC. ADB is an exterior angle of triangle ADC. So therefore, angle ADB is greater than angle DAC. Angle ADB is greater than angle DAC because of the exterior angle property. Exterior angle property. Then, so therefore I can say that angle ADB is greater than angle BAD, that is from 1, isn't it? Because we have proved that angle BAD is equal to angle DAC. So instead of angle DAC, I can write angle BAD. Correct? So now we have proved that angle ADB is greater. So the side opposite to angle ADB is which? AB. Correct? Is greater than BAD. So the side opposite to angle BAD is nothing but BD. So we have proved that AB is greater than BD. So we can say that AB is greater than BD. Why? Because the side opposite to greater angle is greater. Okay, the side opposite to greater angle is greater. Okay, let's move on to the next sum. In this, it says that in figure 3.62, your PT is the bisector of angle QPR. A line through R intersects the ray QP. Okay, they have extended the QP, and when you extend the line R, it intersects at the point S. Prove that PS is equal to PR. Okay, we need to prove that PS is equal to PR. So if we need to prove that these two sides are congruent, first we need to prove that angle PRS is congruent to PSR. So if we prove that these two angles are congruent, then according to the converse of isosceles triangle theorem, we can prove that PR is congruent to PS. Now you can see this PT is parallel to SR, correct? PT is parallel to SR and your QS is the transversal. So we can say that they are forming the corresponding angles, that is angle QPT is congruent to angle PSR. Similarly, your angle TPR is congruent to angle PRS by alternate angles test. Okay, now you will understand when I start writing. So your given is in triangle, instead of that I will just write down that segment PT is the bisector of angle QPR. A line through R intersects ray QP at point S. You need to prove that PS is equal to PR. So first thing it is that segment PT is the bisector of angle QPR. So we can say that angle QPT, your angle QPT is congruent to angle TPR. Okay, QPT is congruent to angle TPR is equal to half of angle QPR. Then line PT is parallel to line SR, where QS is the transversal, then we can say that angle QPT is congruent to angle PSR, corresponding angles. Okay, these are corresponding angles, isn't it? QPT is congruent to angle PSR. Similarly, we'll write that angle TPR is congruent to PRS. So we can also write that angle TPR is congruent to angle PRS. They are alternate angles. Now you can see that QPT is equal to TPR, correct? And here we can see QPT is equal to PSR and TPR is equal to PRS. So because these two are congruent, automatically these also are congruent from 1. Okay, so we can write angle PSR is congruent to angle PRS from 1 and 2. So now we have proved that angle PSR is congruent to angle PRS, correct? So now as the angles are congruent, both the angles of the triangle are congruent, we can say that PR is congruent to PS by converse of isosceles triangle theorem. So we'll write now in triangle PSR, we have proved that angle PSR is congruent to angle PRS, correct? Then therefore we can say PS is equal to PR. Reason, converse of isosceles triangle theorem. Okay, let's move on to the last sum of this problem set. this is actually, I purposely kept it, this is angle B minus angle C. So if the correction is not made in the textbook, please make the correction. It is angle B minus angle C. So in figure 3.63, AD is perpendicular to BC. When it is perpendicular, that means ADB is 90 degrees. Similarly, ADC is also 90 degree. AE is the angle bisector of angle CAB and C dash E dash D. That means the 3 points lie in the same. These 3 points lie on the same line. You need to prove that angle DAE is equal to half of angle B minus half of angle C. So this is a little bit bigger proof, but don't worry, I'll try to make it easy for you to make you all understand. So first they have said that segment AB is the angle bisector of angle CAB. So you can write that BAE is equal to EAC is equal to half of angle BAC, or you can write CAB. I'll repeat, BAE is equal to EAC is equal to half of angle CAB. Okay, we can write that. Okay, then as they have said angle DAE we need to consider. Okay, this angle we need to prove DAE. So we need to consider this DAE always and take this triangle ADB, and then we need to take the triangle ADC. First ADB and ADC. Don't worry, while solving only I will explain you all. So first thing, as I mentioned, first we'll write down given that segment AD is perpendicular to segment BC. Then your segment AE is the bisector of angle CAB and such that C dash E dash D, that they are the points lie in the same line. To prove that angle DAE is equal to half of angle B minus angle C. Okay, so proof, as I said, we'll first write down segment AE is the bisector of angle CAB. So we can say that angle BAE is equal to angle EAC is equal to half of angle CAB. So angle DAE is equal to angle BAE minus angle BAD. Now what does this mean? Angle DAE is equal to the bigger angle BAE minus BAD. DAE is equal to angle BAE minus angle BAD. Okay. Then therefore your angle DAE is equal to angle DAC minus angle EAC. So if you consider this part, angle DAE is equal to angle DAC minus angle EAC. Okay, so now both these sides are equal, so we'll just add them and check by adding 2 and 3. By adding these equations 2 and 3, we'll get twice angle DAE is equal to angle BAE minus angle BAD plus angle DAC minus angle EAC. But we have proved that BAE is equal to EAC. So your BAE and EAC can be cancelled. Correct? So the next step would be that twice angle DAE is equal to angle DAC minus angle BAD. That is from 1. Now we have got DAE on the left hand side, which we wanted. Now this DAC, this entire DAC, we need to find the value of this, and BAD we need to find the value of this. So in triangle ABD, we'll take in triangle ABD, according to the sum of the angles of the triangle are 180 degree. Okay, we'll write down that. So in triangle ABD, angle ABD plus angle BAD plus angle ADB is equal to 180 degree. What is the reason? Sum of angles of a triangle are is 180. Okay, is 180 degree. Sum of the angles of the triangle is 180 degree. Correct? Then what we'll write? Angle ABD plus angle BAD plus angle ADB, because AD is perpendicular to BC, your ADB becomes 90 degree. Okay, so plus 90 degree is equal to 180 degree because it is given. Your therefore angle ABD plus angle BAD is equal to, this is 180, when this 90 goes on the right hand side of the equal to, it becomes minus, so 180 degree minus 90 degree. So we have got our angle ABD plus angle BAD is equal to 90 degree. Therefore we can say angle, because we need BAD on value of BAD, so we'll just keep the BAD on the left hand side and put the others on that side. So angle BAD is equal to 90 degree minus angle ABD. Now your angle ABD is nothing but angle B, so I will write it here as angle B instead of angle ADB. I'm right instead of writing angle ABD, I'm writing just angle B. Now I'll take triangle ADC. So in that we'll try to find out the value of DAC. Correct? So now in triangle ADC, your angle ADC plus angle DCA plus angle DAC is equal to 180 degree. Again the same reason, sum of angles of a triangle is 180 degree. Okay, so in this case you can see your ADC is 90 degree. Okay, so I'll write here, therefore 90 degree plus angle DCA plus angle DAC is equal to 180 degree. Therefore angle DCA plus angle DAC is equal to 180 minus 90, that goes 90 degree. As I said, we need your DAC value, so we'll keep this DAC on the left hand side and write, therefore angle DAC is equal to 90 degree minus angle DCA. Okay, so now we have got the value of DAC, that is we have got the value of DAC as 90 degree minus angle DCA, and we have got the value of angle BAD as 90 degree minus angle B. So this DCA, correct, this DCA is nothing but I can write it as angle angle C. So here instead of writing DCA, I'll write angle C. Okay, now we'll substitute these two values in this and check. So your next step goes as, your next step would be substituting the values. So that would be twice angle DAE is equal to 90 degree minus angle C minus 90 degree minus angle B. Okay, therefore twice angle DAE is equal to 90 degree minus angle C, when you open the bracket it becomes 90 degree plus angle B. So this 90 and 90 gets cancelled, so you are left with twice angle DAE is equal to angle B minus angle C. Therefore this 2, here it is getting multiplied, when it comes on the right hand side it will get divided, so it will be angle DAE is equal to half of angle B and minus angle C. So hence we have proved this. Okay, I hope children you have understood. So with this we finish the problem set 3 and also we finish the chapter. Thank you, children.